Welcome students. Welcome to the class where we discuss regarding the hydraulic circuits. Today we are going to discuss regarding the controlling of single acting hydraulic cylinder. Next controlling of double acting hydraulic cylinder circuit. Next regenerative circuit. These three circuits we are going to discuss detailedly in this part of the class. First we see the controlling of single acting hydraulic cylinder circuit. Okay. So in here, before going to understand the circuits, we have to understand the symbols of circuits. Okay, so one by one I am going to show you here. You can see this symbol, it is a tank symbol. Okay, this is a U shape which is having the line at the middle, so it shows the tank symbol. So this is the filter symbol. Okay, you can see this symbol, it is a filter symbol, so where the filtering process taken place. Next is the pump symbol. So this represents the pump. It's a hydraulic pump. So the arrow mark which is dark filled, it is called as hydraulic pump. If it is not filled inside with a dark line, so then it is a pneumatic pump. So next it is the pressure relief valve. So it is used to relieve the pressure if exceeds in the pressure line. Okay, so then the pressure it is always closed valve. Okay, you can see it is a closed valve. If the pressure increases with the required set pressure, if the pressure increases more than that, then this pressure relief valve opens and whatever the pressure will be released to the tank. Okay, this is the tank symbol again. You can see it is connected to tank. If the pressure increases, the liquid is transferred to the tank again. So this is the direction control valve. Okay, which is operated by the hand lever. Okay, so this is actually a 3/2 valve, means it's having the three ports, 1 2 3 ports, and 2 means two positions. This is one position, this is a second position, so like that it's having 3/2 valve. So 3 port 2 position valve, spool valve, it's called as a direction control valve. Okay, DCV, we commonly call it as a DCV. From the DCV the liquid is transferred to the actuator. So this is a single acting cylinder. Okay, this is a cylinder symbol. This is a cylinder symbol where this is a piston, this is the piston rod, and it is connected to the spring. Okay, you can see the spring in here. The pressure liquid comes here and it will pressurizes the piston to push, it will pushes the piston to the right side and it will make the extension stroke. Okay, so let's see the operation now. So in the single acting cylinder, we will first discuss about the extension stroke, then we will discuss the retraction stroke. So liquid from the tank, it will be transferred to the, it will be pumped to the direction control valve through the with the help of pump, and it will be get filtered in the filter devices. Okay, the whatever the liquid transmitted in the pressure, this is the pressure line. Okay, this is the pressure line. The liquid transmitted here, and it will first move to the direction control valve. Okay, so this is the first position of the direction control valve where the liquid is transmitting from the pump to the actuator. From pump to the actuator, liquid is transmitted. The arrow mark is shown in here. Then it will transmitted here, and it will pushes the, it will transmitted inside this single acting cylinder. We will call single acting because it is having only one port for the input and output of a liquid. Okay, so the liquid come here and it will pushes this whatever the piston in this direction, extension direction, and because of that extension takes place. Okay, so next, if the retraction has to happen, when if you want to make the retraction process, then this direction control lever is going to operated by the manual operation, and because of that this position is shifted to this position. Okay, the position of the direction control valve is shifted from this position to this position. So I am showing in here. So the position is changed in here because of the operation of the lever. So now the liquid from the actuator, is coming back. Okay, liquid from the actuator coming back through this line, and it will be transmitted in the direction control valve from actuator to the tank. Okay, so this is the second position where the liquid is transmitted from A to tank. Okay, actuator to tank. And the another line, the whatever the pumping pressure line, the pressure increases because there is no flow takes place in here in the second position. So and because of that the liquid is transmitted to the pressure relief valve. Pressure relief valve is going to open when the set pressure is reached and the liquid is relieved to the reservoir. So this is the process happens in the single acting cylinder. It is a controlling of a single acting hydraulic cylinder process. It's a hydraulic circuits, so you have to neatly draw the circuits. Okay, this is the extension stroke and this is the retraction stroke. So by that we can control the operation of this single acting cylinder. Okay, so one port is provided at here because for to drain out the air which is trapped at this end. Okay, so like that we can have the application of this single acting hydraulic cylinder. So next we see the controlling of a double acting hydraulic cylinder. Means double acting is nothing but the cylinder is having the two ports. Okay, so we can again see briefly what are the components present in the circuit. First is the tank, second is the filter, third is the pump. Next you can see the pressure relief valve. It is always closed, and this is the direction control valve. It is actually a 4x2 valve. So 4x2, why we call it as there are 4 ports, 1, 2, 3, 4. So 4 ports are provided at here, and 2 positions, means this is the one position and this is the second position. Okay, like that we have the 4x2 means 4 port 2 position valve. It is a direction control valve, DCV. Okay, next is the double acting cylinder. So this is the double acting cylinder. We can find the 2 ports. Okay, one and this one. There are 2 ports in this double acting cylinder for to supply the fluid. So one time the liquid comes here, and the exit of liquid is going to take place at this port, and second position the liquid comes here and the exit of liquid is going to take place at this port. So like that this work is going to take place in the double acting cylinder. Now we will see the operation, how we are going to control it. The first liquid from the tank, it will be sucked by the pump through the filters, and pump pressurizes the liquid and it will transmit the liquid to the direction control valve. In the direction control valve, the first position, the liquid is transmitted from pump to the actuator line. This is the direction which is shown in here. And in the direction control, the liquid, whatever the liquid which is previously present, it will be transmitted back to the tank through the direction control valve. This is the B port. If you consider this is A port, this is B port. From B to tank, liquid is coming from B to, this is the tank symbol. Okay, this symbol represents the liquid is coming back to the tank. So next, the liquid transmitted from DCV to the actuator, the liquid transmitted here, and it will pressurize the piston to move in the extension stroke, and it will pressurize here, piston move in the forward direction, and it will make the extension. The liquid is trapped at here, it will come through this line and it will be transmitted to the tank with the help of direction control. So this is the first position. Okay, in the first position the extension is going to take place. Okay, so this is the first position. If you come to the second position, the liquid from the tank, it will be sucked through by the pump with the help of motor. The filter is going to be filtering that whatever the liquid which enters the pump. Next the pump pressurizes the liquid, and you can see there is a position change in the direction control. Okay, this is the first position. It will be shifted to the second position by the help of the lever. Okay, we can have the many actuations for the DCV. I am here using only the lever. Okay, so in here whatever happens, the liquid comes to the second position. It will transmit it from the pump to this whatever the actuator. You can see the cross line, the liquid comes to here and it will be transmitted to the actuator, and it will pressurize the piston to make the retraction stroke, and whatever the liquid which is present at here, it will transmit it through this line and it will be transmitted to the tank. Just I am not shown in here, there is a symbol, tank symbol we have to show like this. Okay, you have to show here this tank symbol. So liquid is transmitted to the tank. Okay, if there is any excess pressure happens, then the pressure relief valve is going to relieve that pressure through its operation. So like that we are going to control this double acting cylinders in the circuit. So next we move on to the regenerative circuit. Okay, so what is the regenerative circuit? The name only represents that the generation of, means if you have any regeneration, means if you have the generation of power, then by using that power only you can regenerate again. So that is the regeneration process. In here the regenerative process are mainly used to exceed the extension stroke with a higher speed. Okay, so you can see here how it is going to happen. First see the elements. This is the tank, this is the filter, This is the pump which is actuated by the motor. This is the pressure relief valve, and this is the direction control. It is a 4x3 direction control valve. So why we call it as 4? Because it is having the 4 ports, 1 2 3 4, or you can say A B P T. There are 4 ports. Okay, there are 4 ports, and 3 position, 1 position, second, third position. Okay, there are 3 positions which are actuated by the hand lever. Okay, so what happens, and the next is the actuator. We are using the double acting actuator in here. Cylinder is in here. This is the piston, this is the piston rod. So now see the operation. The pump which is going to suck the liquid from the tank, and it will be filtered through the filters, and it will transmit it to the we can see the extension stroke in here. So this is the process is normal. It is common in both extension and retraction. So we will just move on from this position. You can see here the liquid from here, the first position. You can see this is the first position of a 4x3 DCV. So the liquid comes here, and it will be transmitted from P to A. Okay, P to A, the liquid is transmitted, and it will pressurize the piston to move in the extension direction. And the liquid which is present at here, it will be transmitted back to, but you can see the line is not connected to the DCV. The line is not connected to the DCV. It is directly connected to the pressure line. So this is the pressure line. The return line is going to be connected to the pressure line. So what happens in here, the liquid having, for example, it is having the 10 bar of pressure which is coming from the pump, and you can see there is some other pressure which is adding to this whatever the pressure line, and it will make more pressure on this whatever the line. Okay, and because of that higher pressure, the extension will be more faster. Okay, the speed of the extension is going to be increased because of this line connection. So the pressure in here is also having, and the extra pressure is also added. So because of that, the speeding of the higher flow is going to take place, and because of that liquid is going to be make a higher pressure at this position, and because of that extension is also going to be faster. So this action is going to be controlled by this regenerative circuit. So if you come to the second stroke, that is retraction stroke. So this is actually a neutral stroke, neutral position. This is extension position, this is retraction position. So now we have, earlier we discussed the extension position. Now this is the retraction position. So what happens, the pump, the liquid coming from the pump, it will comes here, and it will be transferred. You can see there is no connection in here. Okay, in the DCV there is no connection. So the liquid will be transmitted through this connection, regenerative connection line, and liquid transmitted here, and it will pressurize the piston in this opposite direction. Okay, and that is the retraction stroke is going to take place. Okay, so as the liquid comes here, it will be transmitted through this line. It will have the push of this line, but it is a pump pressure. Whatever the pressure which is experienced at here, it is only pump pressure. There is no regeneration is going to take place in this line. Only small amount of pressure. For example, 10 bar is the pump pressure. That much of pressure is going to be applied at here, but the liquid which is present at here, it will be transmitted back to the tank. Okay, so like that, only the extension is faster, but retraction is normal. It is not having the faster. So the application where we have the faster extension, then we use the regenerative circuits. And you can see the neutral position. In this neutral position, what happens, the liquid is now transmitted from this pump to this actuator. It will be transmitted like this, but as it reaches this end point, there is no extra pressure is going to be applied, and because of that the PRV opens, and pressure relief action takes place. Okay, so like that action is going to take place in the neutral position. Okay, so this is the regenerative circuit. Okay, thank you students. I hope you have got a lot of information regarding the 3 circuits. It will be very helpful in your exams, and if you want to make better experience of this, use some softwares which are related to the hydraulic system, hydraulic circuits, and you can see the animations. Okay, so those animations will help you to understand in a better way. Okay, I hope I will give some brief scenario how the circuits are going to be created and it is going to work. Okay, thank you. If you have any queries, you can contact me. Thank you.